Module 2 is about solving linear equations and inequalities in different methods. It's probably more of what you consider to be Algebra 2. It'll be a direct continuation from many of the concepts you did in Algebra 1. The first example, jumping right in, is solving a linear equation. We're going to solve 1/3 times the quantity of 2x minus 57 plus 1/3 times the quantity of 6 minus x equals -4. And we can do that by first doing the distributive property. We're going to distribute 1/3 times 2x, and that is going to be 2/3 x. 1/3 times -57, that is -19. We will add to that 1/3 times 6, and that's 2. 1/3 times -x would be -1/3 x equal to -4. We're going to combine any like terms that we have. We do have 2/3 x and -1/3 x. When we combine those together, we're not combining them by doing the opposite. They're just on the same side of the equation, so that's just going to be 1/3 x. And when you combine -19 and 2, you get -17. They're not canceling each other out. I oftentimes do that when we have long problems just to make sure I don't forget a term and forget to use a term. And that still equals -4. We're trying to get x by itself, so now we can add 17 to both sides to cancel out that 17 completely. So that'll be 1/3 x equals 13. And then we're going to finish it off by either dividing by 1/3, but dividing by 1/3 is the same thing as multiplying times 3. So let's do it that way. Let's multiply both sides times 3, because when you multiply by 1/3, those cancel, and you're left with 1x or just x, and that will equal 39. And remember what we're finding here. We're finding the values of x that would make the original problem a true sentence, and we can check that by replacing all of the x's with 39 and showing that it does give us a true statement. So if I were to do that, I would have 1/3 times 2 times that 39 in place of x minus 57, and add to that 1/3 times the quantity of 6 minus that 39, and it should equal -4. You do what's in parentheses first. So 2 times 39 is 78, and 78 minus 57 is 21, plus 1/3. 6 minus 39 is -33, and does that really equal -4? 1/3 times 21 is 7, and 1/3 times -33 is -11, and does that really equal -4? And 7 minus 11 does equal -4, so this does check out. Now with linear equations, you should be able to solve for x and get an answer that will check out every single time. That's not necessarily true with other equations that we'll see in this chapter. So there will be some times where we do need to check our answers to make sure that we are correct. Let's see how this applies to a real-world problem. This one says the diameter of Earth is 828 kilometers less than twice the diameter of Mars. If Earth has a diameter of 12,756 kilometers, what is the diameter of Mars? So the question we are being asked is, what is the diameter of Mars? We're going to find the diameter of Mars. So since we're trying to figure out the diameter of Mars, that really should be our variable. So I'm going to use the variable m. You can use x or j or basically any letter you want, but m makes the most sense to me for Mars. M is going to be the diameter of Mars. And this is what we're trying to figure out. And again, it says up here, the diameter of Earth is 828 kilometers less than twice the diameter of Mars. So it also says that Earth has a diameter of 12,756 kilometers. So we can set up an equation by setting that 12,756, that is the diameter of Earth, and it is less than that its diameter Earth is 828 kilometers less than twice the diameter of Mars. So we're going to set that equal to write 828 kilometers less than twice the diameter of Mars. If the diameter of Mars is m, 828 kilometers less than that then twice that would be 2 times m, or 2m minus 828. So there's our equation, and we can solve that equation by adding 828 to both sides. And when you add 828 to both sides, you should get 13,584 equals 2m. And then we will divide both sides by 2. And m will equal 6,792. And that is the diameter of Mars in kilometers. Let's try another word problem. In 1962, Wilt the Stilt Chamberlain set the record for the most points scored in a single NBA game. He scored 28 points from free throws and made X field goals, worth 2 points each. If Wilt Chamberlain scored 100 points, how many field goals did he make? And it says, which equation represents the number of field goals that Chamberlain? That should not be there. I think I changed this from a multiple choice question. You don't get that benefit. We are going to write this equation from scratch. So things you need to know about basketball is that each field goal is worth 2 points. A field goal is when you actually make a basket. You probably never heard it called a field goal before, but it's what it's really called. And so if X represents field goals, it already defines the variable for you. Our equation is going to be, since each field goal is 2 points, it would be 2 times the number of field goals he makes, or 2x. Free throws are 1 point each, and he made 28 points from free throws, so we will add to that the 28 points he made from free throws and set it equal to the 100 points that he scored in a single NBA game. And yes, this is a true situation. The man was a stud. So we're going to subtract 28 from both sides. This has got far smaller numbers than the previous problem. So 2x equals 72, and then we'll just divide by 2. And we get x equal to 36. So he made 36 field goals, or 36 baskets, in a single NBA game. On occasion, we will have equations that do not have all numbers or all numbers in one variable. Sometimes it will have multiple variables in it, and you will be required to solve for a specific variable. You've actually done this already when you change a linear equation from standard form and solve it for y, but it's not always just about lines. The formula for the perimeter of a parallelogram is P equals 2a plus 2b, where a and b represent measures of bases. Solve the equation for b. So it tells us the equation already. It's P equals 2a plus 2b. And when it says solve the equation for b, that means we're going to get b by itself. And we can do that very similar to when you get y by itself. We're going to subtract this 2a from both sides. And p and 2a, you can't actually subtract those because they're not like terms. So it's just p minus 2a. They have to have the same variable part to be added or subtracted. And that is going to equal 2b. And then we'll divide by 2. And when you divide by 2, remember there is a 1 in front of that p. So that means 1p divided by 2 would be 1/2 p. Negative 2a divided by 2 would be just negative 1a, or just negative a. And that will equal b. And we have solved the equation for b. Let's try the next one. This is a equals 1/2 h a plus b. This is actually the formula for the area of a trapezoid. This time we're going to solve for h, so we're going to get h by itself. It is going to be very tempting to take the distributive property and do 1/2 h times a plus b. Don't really want to do that. That's going to actually make the problem more complex. But since we have 1/2 being taken times the h times a plus b, that means we have all multiplication that's happening to the h. Because if we did distribute the h, we would multiply h times a and h times b. So everything involving the h is multiplication. That means we're going to cancel out the half. And instead of saying dividing by a half, let's instead use our keep, change, flip rule. Dividing by half is the same thing as multiplying by 2. So I'm going to write this as multiplying both sides by 2. Multiplying a half by 2 cancels out because a half of 2 is just 1, and the 1 wouldn't be necessary anymore. So you'd be left with 2a equals h times a plus b. And again, we are trying to solve for h and try to get h by itself. So to get h by itself, let's divide both sides by the a plus b. So solved for h, the a plus b's would cancel. The answer would be 2a, 2 capital A over little a, and those are actually different variables, a plus b.